Before we begin with our topic, ZTNA Zero Trust versus VPN explained, which one is more secure? We will have background. Have you ever connected to your office network using a VPN? Maybe you've worked from home, opened your VPN client, entered your credentials, and suddenly had access to your company's internal network. Now here's an important question. If someone steals your VPN credentials, or your laptop gets infected with malware, what stops an attacker from moving throughout your entire corporate network? The answer is, often, not much. And that's exactly why organizations around the world are replacing traditional VPNs with Zero Trust Network Access, or ZTNA. In today's video, we're going to compare ZTNA and VPN from the ground up. We'll understand how they work, why Zero Trust is becoming the new security standard, and how modern enterprises like Microsoft, Google, and many Fortune 500 companies secure remote users without relying on traditional VPNs. By the end of this video, you'll confidently explain the differences in interviews, troubleshoot real deployments, and understand where each technology fits in an enterprise network. Let's begin. Here is today's roadmap. What is remote access? What is VPN? How VPN works? Problems with VPN. What is ZTNA? How ZTNA works? VPN versus ZTNA architecture. Packet flow comparison. Enterprise example. Security comparison. Performance comparison. Troubleshooting. Best practices. Interview questions. Summary. Let's begin with why remote access exists. Before comparing VPN and ZTNA, let's understand why remote access exists. Years ago, employees worked almost entirely from the office. Applications lived in a central data center, and users accessed them from the corporate LAN. Today, that's no longer the case. Employees work from home, hotels, airports, customer sites, coffee shops. Applications also live everywhere. Corporate data centers, AWS, Azure, Google Cloud, Microsoft 365, Salesforce. The challenge is simple. How do we let remote users access business applications securely without exposing the enterprise network? Two major approaches emerged. 1. Traditional VPN. 2. Zero Trust Network Access, ZTNA. Let's explore each. What is a VPN? VPN stands for Virtual Private Network. Think of a VPN as building a secure tunnel across the public internet. Imagine your company headquarters as a large office building. Normally, the front door is locked. A VPN creates a secure tunnel from your laptop directly into that building. Once you're inside, you're often treated almost like you're sitting in the office. That's convenient, but it also introduces risk. How VPN works. Step 1. User launches the VPN client. Step 2. The client authenticates using credentials, certificates, or MFA. Step 3. An encrypted tunnel, IPsec or SSL VPN, is established. Step 4. The user receives an internal IP address. Step 5. Traffic destined for corporate resources flows through the VPN gateway. Step 6. The gateway forwards traffic into the internal network. The key point is this. A VPN grants network-level access. Enterprise VPN flow. Imagine an employee working from home. VPN connection flow is like laptop, internet, VPN gateway, headquarters firewall, corporate network, application server, database. Once connected, the employee may have visibility into multiple network segments, even if they only need access to one application. That's where the security challenge begins. Problems with VPN. VPN solved remote access for many years, but modern cloud environments exposed several weaknesses. Problem 1. Broad network access. VPN connects users to the network, not just the application. If compromised, attackers can move laterally. Problem 2. Implicit trust. After authentication, users often receive broad access. Trust is granted once and maintained for the session. Problem 3. Bottlenecks. All traffic frequently passes through headquarters. This increases latency. Problem 4. Scalability. Large enterprises may have 20,000 users, thousands of VPN sessions, hardware limitations, bandwidth constraints. Problem 5. Complex firewall policies. More VPN users mean more ACLs, routes, and segmentation rules. Management becomes difficult. What is ZTNA? ZTNA stands for Zero Trust Network Access. The philosophy is simple. Never trust. Always verify. Instead of connecting users to the corporate network, ZTNA connects users only to the specific application they are authorized to access. Imagine arriving at a secure office building. With a VPN, security gives you the master key to the building. With ZTNA, security escorts you directly to the one meeting room you need. You never receive access to the rest of the building. That is the essence of zero trust. How ZTNA works. Let's walk through the process. Step 1. User opens the application. Step 2. ZTNA client identifies the request. Step 3. Identity provider authenticates the user. Step 4. Device posture is checked. Questions include: is antivirus running? Is the OS patched? Is disk encryption enabled? Is the device compliant? Step 5. The ZTNA controller evaluates policies. Step 6. Only the requested application is published. Step 7. Encrypted connection is established directly to that application. No network visibility. No lateral movement. No unnecessary access. VPN versus ZTNA architecture. In a traditional VPN, user connects in this pattern: remote user, internet, VPN gateway, corporate network, file server, database, HR, finance, ERP applications. The user enters the network first. In ZTNA environment, user connection pattern is: remote user, internet, ZTNA cloud, identity verification policy engine, specific application only. The user never joins the corporate network. Instead, the application is securely published. Packet flow comparison. VPN packet flow. Laptop. VPN tunnel. Firewall. Corporate LAN. Application. Risk. If malware exists, it may scan internal systems. ZTNA packet flow. Laptop. Identity verification. Device health check. Policy engine. Specific application. No LAN access. No subnet visibility. Least privilege enforced. Real enterprise example. Imagine a global financial company with 30 branch offices, 12,000 employees. Microsoft 365. Salesforce. SAP. Internal HR portal. Old VPN design. Every employee connects to headquarters. Internet traffic hairpins through the data center. High latency. Large VPN concentrators. Complex firewall rules. Modern ZTNA design. Employees connect to the nearest cloud POP. Identity is verified. Device health is checked. Users access only. SAP. HR portal. Salesforce. Nothing else is exposed. Performance improves, and security is significantly stronger. Troubleshooting. When users report access issues. 1. Verify identity authentication. 2. Check MFA status. 3. Confirm device compliance. 4. Review ZTNA policy logs. 5. Verify application connector health. 6. Test DNS resolution. 7. Check certificate validity. 8. Inspect cloud connector status. 9. Review user group membership. 10. Confirm application publishing rules. Always start with identity, not the network. What best practices are? Heavy checkmark enable multi-factor authentication, MFA. Heavy checkmark use identity-based policies. Heavy checkmark implement least privilege access. Heavy checkmark continuously validate device posture. Heavy checkmark monitor user behavior. Heavy checkmark enable detailed logging. Heavy checkmark integrate with identity providers. Heavy checkmark segment critical applications. Heavy checkmark review access policies regularly. Heavy checkmark replace broad VPN access with application-level access where possible. Interview questions and brief answers. Question 1. What is the primary difference between VPN and ZTNA? Answer. VPN provides network-level access, while ZTNA provides application-level access based on identity and policy. Question 2. Why is ZTNA considered more secure? Answer. ZTNA follows the zero trust principle of never trust, always verify, continuously validating users and devices before granting access. Question 3. Does ZTNA replace VPN completely? Answer. Not always. Many organizations use both during migration, but ZTNA is increasingly replacing VPN for user-to-application access. Question 4. What is lateral movement? Answer. It is when an attacker moves from one compromised system to other systems inside the network. ZTNA greatly reduces this risk by preventing broad network access. Question 5. What checks does ZTNA perform before granting access? Answer: user identity, MFA status, device posture, compliance, location, risk score, and access policy evaluation. Question 6. Which technology is better for cloud-first enterprises? Answer: ZTNA, because it provides secure, identity-aware access to applications without exposing the internal network. Let's recap what we've learned today. VPN creates a secure tunnel into the corporate network. ZTNA provides secure access only to the specific application a user is authorized to use. VPN relies on trust after authentication, while ZTNA continuously verifies identity and device posture. ZTNA minimizes lateral movement, improves security, and aligns with modern cloud-first architectures. Many organizations are adopting ZTNA as a key component of Secure Access Service Edge, SASE. As an enterprise network engineer, understanding both technologies and knowing when to use each is essential for designing secure remote access solutions. If this video helped you understand ZTNA versus VPN, please like, subscribe, and turn on notifications for more deep technical content from SASE Cloud Networking. In the comments, let me know which topic you'd like next. ZTNA Packet Flow Deep Dive. ZTNA versus SDP. ZTNA with Prisma Access. Cisco Secure Access, ZTNA. SASE Architecture End-to-End. Real Enterprise Zero Trust Deployment. Thanks for watching, and I'll see you in the next enterprise networking tutorial.